Hello everyone, I'm here to explain about the topic time and space complexity. What are they exactly? Time complexity. The amount of time required to execute an algorithm is known as time complexity. Space complexity. The amount of memory required to execute an algorithm is known as space complexity. Big O notation. Used to describe the amount of time a given algorithm would take in the worst case based on the input size n. For the sake of analysis, we ignore constants. Big O of C star f of n equal to big O of g of n. So this is an example we take. This is a bubble sort algorithm. So if we take the sample data, the following this here, the following represent a sample input array of size n equal to 6 to our bubble sort algorithm. This is a look after each pass of the for loop, where it must go from 0 to n minus 1. So these are the total number of swaps in this bubble sort for each for loop. If we add it up, n loops through while star n minus 1 loops through for the n star n square minus n. As size of n grows larger, only the n square factor is important. So big O of f of n equal to big O of n square. So the best case for any sort algorithm is big O of n. And the bubble sort can achieve that if its data is already sorted. On average, it is one of the worst sorting algorithms. Other ways to measure time complexity. The average case. More difficult to compute because it requires some knowledge of what you should expect on average, but is a best measure of an algorithm. Bubble sort shares the same worst case time complexity with insertion sort, but on average is much worse. The best case. Not exactly the best measure of an algorithm's performance, because unless it is likely to continually be the best case, comparisons between algorithms are not very meaningful. A quick look at space complexity. In our previous example, our array considered of an integer array and three other variables. Space complexity is typically a secondary concern to time complexity, given the amount of space in today's computers, unless, of course, size requirements simply become too large. Why is time complexity important? Because it allows for comparisons with other algorithms to determine which is more efficient. We need a way to determine whether or not something is going to take a reasonable amount of time to run or not. Time complexity of 2 power n are no good. For n equal to 100, it would be this large number operations, which would take a super long time. One of the big questions in computer science right now is the finding a way to determine if an NP complete problem can be computed in polynomial time. NP complete problems are problems that cannot, to our knowledge, be solved in polynomial time, but whose answer can be verified in polynomial time. So that's all for today. Thank you, guys.